Hello everyone. So today let's start our journey by implementing the simplest data structure, that is arrays. So arrays, as we all know, is a contiguous data structure. By this I mean whenever we store an array, it will store in a contiguous form in the memory. Contiguous means one after another. Uh, so it would be saved something like this only in the memory. Also, let's see what all operations can be done. Basically, there are two operations: insertion, and in insertion we can insert in the end, we can insert in the beginning, or we can insert at a given position. And same are the operations in deletion as well. So today we'll be implementing these operations. Let's start. So let's create a method named. So okay, one more thing before creating the methods, we have to define the variables. Let's declare some global variables. First, uh, the array itself. So arrays in Java are declared in this way. Okay, so for declaring this array, we need to specify the size because it is mandatory for us to provide the array with size at the time of the declaration. So also, what if we see the insertion, we have to look into the scenario when uh, we are inserting in the array and we have the array already full. For example, the size of array is 6 in, as we can see in this example, and we want to insert 7. So I cannot insert 7 if my size of array is 6. So for that I would have to increase the size of the array and then do the insertion. So what we will do, we will take the initial size of the array, and whenever a new element comes, uh, when array is already filled, then we would double the previous size, original size of the array. So for that, let's create a variable capacity, and let's keep the initial capacity as 5, and I'm declaring the array size as this capacity. Okay, another thing that we have to keep in mind, we have to keep track of is the current size of the array. Like for example, if the size of the capacity of the array is 5, but right now 3 elements are filled in this array which has 5 capacity, so we have to keep track of the size as well. So for that, let's create a variable int size, whose initial value of which would be -1. Now we are ready to start with the creation of our methods. Let's create a method for insertion first. Public insert at the beginning. Okay, public void. Let's create private void insert at begin. So this method would return void, and in arguments will pass the element itself. Okay, so for inserting at the beginning, first we would have to check if the array is already filled completely. For example, if we have capacity 5 and we already have 5 elements in the array, then we would have to resize it. So let's add a condition for it here. If Size would be starting from 0. So if there are 5 elements in the array, then the size would be 4. So if size plus 1 equals to capacity, if size plus 1 equals to capacity, that means that our array is full. If that's the case, then we will resize our array. Let's quickly create a method of it. Also, before implementing our insert method, let's implement the resize method. So what would resize method would do basically? It will basically copy the elements of this array which has initial size of 5 to a new array which will have the size of double the size of this array, which would be 10, and save it in this array. What I mean is, let me show you. We'll declare a new array, let's call it a temp array, and the size of it would be the double the size of current capacity. It would be this. Okay. Oh, sorry. It would be smaller. So we have declared a temp array which has double the size of current array, and now we need to populate this array with current elements. So for that, we would simply be copying elements from current array to this new array. That temp array ith position, I would add ith position element of ARR array. This will copy my complete array in temp array, and now I will put the temp array in array, and also increase the size of capacity by 2. Okay. If you are not aware of this, this simply means capacity equals to capacity into 2. This capacity equals to capacity into 2. It can be written this way also. So we have resized our array. Now let's move on to our insert. So for insertion at the beginning, for example, I want to insert 0 in here. I want this to be like 0, 1, 2, 3, 4, 5. What I have to do, I have to shift each array. 1 should be at second position, 3 should be at fourth position, and 5th should be at the 6th position. So for that, first we'll put 5 on the 6th position here, then we'll put 4 on the place of 5, then we'll put 3 on 4, 2 on 3, 1 on 3. After overwriting all these, we would have this position empty, and we can simply insert our new element here. Okay, so let's do that using a for loop. We'll start from the end. So our loop will start from size, and it should be greater than or equal to 0, I plus plus. Okay, so now what we'll do, we will shift the array elements. For shifting, simply just arr of I plus 1 equals to arr of I. So all the elements up till 0 are shifted, and now we simply have to insert at 0th position our element, right? And also we have inserted a new array, so we'll increase the size. So this would be our insert at begin. uh, let's insert at end. Let's create a method for that. Here also we will check the same condition. If size plus 1 equals to capacity, then we will resize it and then insert. So for inserting at the end, we simply have to insert at size plus 1 to element and size plus plus, right? So we have inserted at the end of the array, as simple as that. Now if we want to insert at some position, let's create a method for that as well. For inserting at a position, first let's check if the position provided is not less than 1. For also the position 1 means 0th index here. Okay, so if position is less than first position, then it's an invalid position. Or if position is greater than size plus 2, then also it would be invalid. What I mean by this condition is, if we get a position, let's suppose 6, let's suppose I get a position 7, and I have 5 elements in here, so my size would be 0 1 2 3 4, right? So size plus 1 would be 5, so I can insert at 5th position, but I cannot insert at 6th position, right? So if my position is uh, 7th, okay, so 7 would be greater than 2, so I cannot insert at 7th index, so that will fail it. That should simply print sys out invalid position, right? And just return. When I write return, it would not uh, execute any of the code below the return statement. Also, let's provide a position. I haven't provided it yet in the argument. Size plus 2, simply, if I explain it again, if you guys are not clear, if position is greater than the actual capacity of array, which is size plus 1 plus 1, if it is greater than that position, that means we are trying to insert 2 position ahead of the initial capacity, then it would not be possible. Then it would simply break the continuity of the array. Okay, after this is satisfied, uh, we would check if we need to resize the array. Like if the current size of array is 5 and we want to insert at 6th position, so we would have to resize it. So for that, let's resize it. Same condition. Okay. So now we have to insert at a position. For inserting at the beginning, what we did, we inserted, uh, we just shifted all the elements up till the 0th index because we had to insert at 0th position. But now we have to insert at a given position, so we'll do the shifting up till that position. For example, I want to insert at 3rd position, so I will shift 5, I'll shift 4 at 5th position, and I'll override 4 with 3. Now I have this place empty, I'll insert it here. Don't need to do anything with the elements previous to this position. So in reality, what it would look like, for int I equals to size same, it should be greater than or equal to position minus 1. Okay, position minus 1 because size is starting from 0, index is starting from 0, and position is starting from 1, and I minus minus. Now let me shift the arrays, same old technique. Array of I plus 1 would be 5. All the shifting is done. Now we have our position place empty, so we'll simply position minus 1 would be element. So we simply insert the element and increase the size of array by 1. So this is our insertion operation. Okay, so let's check this. Also for checking, we need to write a print method. Let's write a print method. How do we traverse through an array? We simply traverse each element of the array and print it. So for that, the same old for loop for int I equals to 0, I less than the less than equals to size I plus plus. Sys out. We'll sys out in the same line. We'll sys out the element of the array. After that, go to the new line. Print ln means print new line. Print and then go to new line. So here I am not printing and then going to new line. I am simply appending it in the same line. So this is a print statement. Let me see. This is our insert at beginning. This is our insert at end. This is our insert at position, and resize and print methods. Let's create a main method and test our methods that we have created. To call this, I have to create an object of this class. Created the new object of this class, and let's call the methods. Let's insert, do some insert operations. Ob dot insert at begin 3. Let's insert 2. Let's insert 1. Now insert, let's call insert at end. You want insert at end 4. Sorry about that. Ob dot insert at end 5. And let's ob dot insert at position. Element would be 6th and position would also be 6. Let's check this out. Also guys, at insertion at pause, in this method our resize method will also be called when I call this method, because the initial capacity, as you guys can see, is 5, and when I try to insert a new element, then it will resize the array, it will change it to 10 and then insert it at the position 6th. Also let's print the array, check, it should be 1 2 3 4 5 6. Let's run this. For running we can simply press Alt Shift X and J. Okay, so here is the error. Index out of bound, exception 5 at this. We are trying to insert in the beginning, right? I think I is greater than equals to 0. Okay, I plus plus 5 plus 1. Maybe we are not able to resize it. Let's see the resize. So okay. This seems correct. Okay, so whenever we are stuck like this, the simplest way to see where the error is, we can simply debug our application. So for debugging, I will simply debug it. I have added a breakpoint there. Oh, this is my debug perspective. So right now the element is 2. Okay, the element is 2 that we have to insert. And I is 0. If I see size, that is 0, and array has 3 in it already. Okay, so size is 0, I is 0, and we are trying to shift the 0th position element to first position element here. So let's go ahead, step over. So this is shifted one position ahead. Now again it enters in here. Why? Because I is greater than equals to 0. Okay. Now I is 1. Oh, the it should be less than equals to 0. That's a silly mistake. Okay. So now it should work. Let's run it right away. I'm sorry, that was right. That was right. It should be greater than equals to 0. My bad. The problem is when we are traversing backward in the loop, it should be I minus minus, not plus plus. Hmm. That's why we need to work hard. Yeah, let's run this. So, our expected array 1 2 3 4 5 6. First we inserted 3 2 1. Then we inserted 4 in the beginning. We inserted 3 2 1, and then we inserted 4 5 6 4 5 at the end, and 6 at the 6th position. Okay, moving ahead, let's do the delete operation. Private void delete at beginning. So for deleting in the beginning, what we need to do? We need to delete this item. So for deleting it, we need to shift 2 at 1's position, 3 at 2's position, 4 at 3's position. We need to shift to the left. So for shifting, we'll simply do the same way we did for insertion, but in the reverse order. What I mean by this is, let me show you here. Also, before deleting, we have to check if our array is already not empty. Let's check that condition. If size is 2 minus 1, that means our array is already empty and we are trying to delete from an empty array, which simply states underflow condition. Okay. Okay. Also, let's return if this condition arises, and then if this is not the case, size is greater than 1 or greater than 0, then we can delete. So for deleting, let's write a for loop. We'll start from 0th position because we want to delete at the beginning, and we'll shift up till the size of the array equals to size I less than size. Okay, we start at 0, we simply put I plus 1 equals to I. So I less than size I plus plus array of uh, element at position I plus 1, sorry, at I will be equal to element at position I plus 1, right? This will shift, put the next position element to the current position, and we simply say size minus minus, This will be our delete at beginning. Now move ahead. Moving ahead, we have delete at end. For deleting at end, also we need to check our old underflow condition. Okay. Then we just have to delete at the end, so we can simply do size minus minus. This just delete will just consider the array from 0 up till the size, no matter what is after that size. So we'll just simply ignore the element after the size. Now let's implement deleting from a position. So okay, for deleting at a position, first let's check if position that we are provided with is not less than 0, less than 1, or position is not the same condition that we basically put in this. But here the position should not be greater than size plus 1 instead of size plus 2. Right? Uh, if that's the case, we'll write invalid position for deletion and simply return. If position is correct, then we need to check the underflow condition. Let's just simply copy it from here. If position is correct and our array is not empty, basically if we look at it, if our array is empty, then size would be minus 1, and even if the position is 1, it would be greater than 0, right? So it would say invalid position for deletion. Basically this is handling our underflow condition, but if we want to handle it separately, we can write it before this condition. Okay, so now uh, deleting from a position, it is similar to what we did in delete at beginning. We are just shifting the elements, but at delete at beginning we were shifting from 0, but at delete from position, let's suppose we have to delete third element. Okay, so what we will do, we will simply put 4 in 3's position, put 5 in 4's position, and then we are done. So we don't have to worry about elements before 3. We have to start from position up till the last element of the array. Let's implement that. Okay. Point I equals to position minus 1, starting from position minus 1 and traversing up till up till size or size plus 1 will traverse up till we have to will traverse up till size. I should be less than size before the size, I mean, so I plus plus now array I equals to array I plus 1, and it is simply done. If we have one element in the array, what will happen? The position minus 1 will say 0, and size would be also 0, so 0 would not be less than 0, so this will not be executed, and size will be simply decremented by 1, and we will simply ignore that 0th position element and consider our array to be empty. So our deletion operations are done. Let's check. P dot delete at beginning and ob dot delete at end and ob dot delete at position. So let's delete at second position, so it will delete 3. uh, our final expected output would be 245. Let's see if that's the output. Alt Shift X. Yeah. So we deleted 1 from the beginning, 6 from the end. We got 2, 3, 4, 5, and then we deleted second element. So we got 2, 4, 5. So this was it. That was our array implementation. We did insertion and deletion in the array at beginning and end at a given position. Also, we resize the array whenever required, and at the same time, we kept in mind the corner cases that should be taken care of. The underflow and overflow conditions are all taken care of. Right, so this was pretty much it for this video. For next video, our topic would be implementing linked lists, singly linked lists, what linked lists are and how they are implemented. We'll talk about it in the next video.